All right, let's look at FRQ2. On initial day of sales, which is denoted as T equals 0 for new video games, there are 40,000 units of a game sold on this day. On 91 days later, when T equals 91, there are only 76,000 units of the game sold. The number of units of the video game can be given by the following modeled equation. Gotcha. Let's get started. All right, so we're going to write two equations that can be used to find the values of A and B, and then we're going to go ahead and actually find those values. So I'm going to move this up, and I'm going to start by writing out this modeled equation. G of T equals A plus B ln of T plus 1. Now, what do we know? We know that on day 0, there are 40,000 games sold, and we know 91 days later, there are 76,000 games sold. Okay, so our first equation, I'm going to substitute in for G of T, I'm substituting 40, A plus B ln. Now, this is when our initial day was 0, so T is times 0. Our next equation is going to be 76, so 76,000 is A plus B ln of, again, 91 plus 1. Those are my two equations. And then in the next part, we're actually going to solve. So I'm going to start here, and I'm going to, so this is going to be part 1, and here's part 2 of A. Okay, how do I go about solving this? So 40 equals A plus B times the ln of, well, 0 plus 1 is 1. Now, if you did not know that the ln of 1 is 0, let's think about that. Ln, another way to write it, is log base e, and we know that e is a number. So any number, if you raise it to the 0 power, you end up with 1. E to the 0 equals 1. So that's how this portion is equal to 0. E to the 0 equals 1. So I'm going to replace this portion with 0. And now we can easily see that A plus, well, B times 0 is, is 0. And so 40 equals A. So I have to resist not circling the final answer. Hopefully you remember not to do that. If we do circle, it negates the work that we just did. Okay, let's go on to the next part. So I'm going to go back up here to this equation. And I'm going to push this back up, and I'm going to write down, let me switch the colors here so it's easier for you to see. 76 equals 40 plus B times the ln of 92. Start by subtracting 40 to both sides. I have 36 equals B times the ln of 92. To isolate B, I'm going to divide by the ln of 92. Make sure you're showing all of your work, and then you're just using that calculator to assist you here. So let's take our calculator. Did I already put it away? Nope, got it right here. And I'm going to type in 36 divided by the ln of 92. And now, because it's an approximation, I'm going to make sure to use that. So we have 7.961. So I have done A part 1 and 2. Let's now go on to part B. Okay, part B, there's 3 parts to part B. We're going to start with the first part. It says, given the data, find the average rate of change from T equals 0 to T equals 91. Okay, so what we know is we know that G of 0, using this model, and the data up above, we know that on the initial day, we are at 40,000, and then we know that 91 days later we're at 76. So in order to show my work here, I have G of 91 minus G of 0, and then what is our output value for the 91st day? It is 76, and our output value for the initial day is going to be, oops, sorry, I meant to replace this, 76 and 40. So this is equivalent to 76, this is equivalent to 40. And then on the bottom is going to be in terms of T, so this is going to be 91 minus 0. So this is your input value, this is your input value, this is the output value for 91, and this is the output value for 0. 36 over 91. I'm grabbing that calculator and taking 36 and dividing it by 91. and I have approximately 0.39, let's round to the nearest thousands, 6. Now we do need to put a title with this. So our title for this is going to be thousands of games sold per day. All right, let's go on to the second part. Okay, for the second part, we're going to use this average rate of change to estimate the number of units of videos sold. So they're thinking of this in terms of using a linear function. So remember, a linear function is y equals mx plus b. Now we just figured out that rate of change between those 2 points. So if I was to graph this, let's go up and so you can see this actually. Let me go and show you this. And hopefully visually this will make sense. I'm going to plug this in. So we know that this is a great model to determine how many games were sold after a particular point in time. We know that A was 40, and we know that, I gotta think here, A was 40 and B was 7.961. And that's times the ln of x plus 1. Okay, we've got that. Now the window, we go all the way out here to 91, so let's go up to 100. So this shows the model of this equation where I could determine it. Just giving you an example here, I could say, okay, watch this. On the initial day, see there's 40, and on day 91, we can see there's about 76, and that's exactly what the information that was provided to us, correct? And so what they now want us to do is they want us to create a secondary model. It doesn't mean it's going to be a better model, and they want us to do a secant line. So they want us to go directly from when t equals 0 to t equals 91. So like we're going to draw a straight line here, and we're going to come up with this equation of the secant line from when t equals 0 out to t equals 91. Okay, here we go. So to do this, we're going to use that average rate of change, which was 0.396 x, and then this is always your initial amount. So the initial amount, the output was 40,000. So this is the equation I have of the secant line and the secant line from 0 to 91 that we just created, okay? So let's go ahead and let's plug that in. We have 0.396x plus 40. We can see that, right? This is the secant line from t equals 0 to t equals 91. Okay, now it says after you create this, estimate the number of video games that would be sold in thousands on the 50th day. So 0.396 times 50 plus 40. Okay, you ready? Now we can go ahead, and there's two different ways we can do it. One way is second trace value, and I can see it on day 50, and I want to go down to the red, so I think about 59.8 thousand. So sorry, you can't see that. Again, I went second trace value up to 50, and I use the arrow to go down. This is the secant line that I'm trying to estimate using this model. So 59.8 thousand. Another way to do it is to type in the 0.396, take it times 50, and then add that 40 to it. And we can see that we get the exact same number. So this is 59.8 thousand games sold on the let me see what on the 50th day. I just want to make sure on the on the 50th day. Okay, it says it wants us to show the work, so we can see exactly what we did in order to achieve this. Let's go on to part 3 of. Okay, so part 3 says we're going to use that equation. We're going to say A of t represents the equation that I just did. That secant line from t equals 0 to t equals 91. So 0.396x plus 40. Okay, that's that secant line. It represents estimate the number of units sold in thousands using the average rate of change. So when A equals 50, which we found in our previous part, we can see that if we look up here, and I'm a visual learner, so we can see, this is what it's saying. Oops, so sorry, second trace value at 50. So it's saying right here that we can see that using this model, that secant line model, produces a less output value than the initial model that tells us in thousands how many games are sold on a particular day after the initial day of sales. Explain why. this is true for all values from 0 to 91. Well, we can see that the secant line, which is A of t, from 0 to 91 produces output values that are consistently less than the output values of g of t. And I think I'm going to go ahead and just show what this looks like. So on my paper, I'm going to go ahead and see exactly what we have here. So this is 40, this is 0, we'll go up to 91 and just kind of draw this graph here so they can see it. And I'm even going to mention that g of t is concave down. Both are increasing, but it is concave down, creating that arc shape. Okay, let's go on to the next part. Okay, so our question here, if I go up above and look, says the makers of the video game reported that the daily sales of the video game decreased after day 91. Explain why the error in the model G increases. So we have to understand that an error is what you predict minus actually what happens. And so I went ahead and I expanded. So instead of ending at 91 or 100, I went out a little further and then did zoom fit. And so here we can see that the predicted value of g of x is increasing. So if we look after 91, this is still increasing. It's increasing at a slow rate. So the model shows that after 91, after t equals 91, it continues to increase at a slow rate. But the video game makers say the video game has reported that the daily sales actually decrease after 91. So that's where we have a discrepancy between what the model actually produces and what's actually happening. So the error in model g of t occurs when t is greater than 91 because the model continues to show an increase in video game sales while the makers of the video game reported a decrease in sales. So what was actually happening did not match up with what was predicted to happen by the model.